Welcome to the Core Quantitative Methods course. In this first video, I'll introduce the course and I'll talk a bit about what quantitative methods actually are. So what are quantitative methods? That is the collection of ways to answer a whole range of questions about how the world is and how the world works. So for example, we might want to ask, how rich are the countries at the moment? What's the income of countries at the moment? We might want to ask, is there a link between national income and child mortality? And we might want to ask questions like, do cash transfers actually help in reducing child mortality? To answer these kinds of questions, we need to go through a whole range of steps. The first step is actually gathering the data, figuring out what the right data is to use for our problem. Then we need to explore the data, and quite often we do that visually. In this course, we'll spend quite a lot of time on visual data exploration because that's the easiest way to get a sense of what's actually going on. Next, we might want to summarize the data. We might want to use descriptive statistics to be able to tell people what a typical income is, what a typical level of child mortality is. In the next step, we might want to generalize findings and quantify our confidence. So if we find a relationship with a certain sample of countries in a certain year, how confident are we that this is actually true across countries, across time? And that's what inferential statistics is all about. Generalizing from our observations to a broader set of cases. And then communicating findings really matters. We'll not spend a huge amount of time on that in this course, but we'll start thinking about how to actually use graphics and words to communicate the findings of quantitative research effectively. And throughout, we want to balance doing these things and being able to critique scientific literature that we read and maybe all the things encountered in the media. And just being able to do one is almost a precondition for being able to do the other. The course that we are about to embark on is structured into 3 5-week modules. The first module is really just about appreciating quantitative methods. What are these methods? How can we explore some data sets? How can we describe these data sets? In the second module, we'll start more on inferential statistics. So how can we make valid scientific claims based on experiments, based on observations? And in the third, we'll go deeper into that and look at some slightly more advanced inferential statistical methods. Throughout, we'll spend time reading published research, critiquing that research, and practicing how to do these things in R. How learning will work in this course is a bit different from some other modules. So it's really essential that you engage with the videos, that you watch the videos in advance, and also that you complete some other preparation tasks. All of that will be on learn.gold. The reason for that is so that we can actually spend class time with interactive things, really addressing your questions, looking at interesting research, and practicing how to actually use R and how to use other tools. Apart from that, I'd encourage you to do the weekly homework that will be available, to submit them, but that's optional, and it's less important than the preparation for class. I'd also encourage everyone to take the 2 exams because I see them as an integral part of the learning journey. They'll be given after 10 weeks and after 15 weeks, and you'll have 4 weeks at each point to complete them. Of course, for some of them, these exams are actually required, but as I said, I'd encourage everyone to do them. And then for each class, I'd ask you to bring your questions so we can then spend time practicing the methods and critiquing research. Obviously, quantitative methods are about numbers, so some of the students are worried about how much maths is involved. And clearly, for now, the computer will be doing all the hard maths. When statistics started about 100 years ago, a lot of it was number crunching. Those days are gone, fortunately. Still, all of the statistical techniques can be expressed in fairly complicated formulae, but it's up to you to what extent you want to engage with them. If you find it helpful, by all means, look at the statistics textbooks and make sense of the formulas, but don't memorize them. You don't need them for the exams, and you don't need them for practical work with quantitative methods. However, you do need to understand some basic maths concepts. Clearly, subtracting, adding, dividing, multiplying should be familiar to all of us. But then there are some things you might have forgotten since you had maths in school: squaring, taking a square root, dealing with percentages, rounding numbers. If you're unsure about any of these, look at learn.gold for a reference, for a pack of reference slides. And obviously you can ask questions whenever anything is unclear. Having said what all these quantitative methods are, there's really one thing at the core of it all, and that is variables. Ultimately, everything we do is about variables. So what are variables? Well, as soon as we have decided what we're going to study, what the object is it people, countries, institutions, as soon as we've decided that, we can identify things that vary between the objects that we are studying. So anything that varies across the objects of study is a variable. Some of the variables are numerical. Some of them we can actually measure: height, grades, income. Some variables are categorical. So we might have gender, we might have the subject that someone gets a grade in, we might have an occupation. There are also some variables that are neither of those. There's unstructured text. When you look at big data sets, we're not going to look at that in this course. So our two variable types that we're interested in are numbers and then categories. The other really important thing for variables is to think about operational definitions, because with any variable, we're trying to capture something that's out there in the world. That's the point. So we think there is some attribute in the world and we want to express its size. So we need to think about the correspondence between our numbers and these attributes. And the way we do that is by actually defining how we measure variables and defining it quite specifically. In some cases, once we have defined it specifically, we have solved the issue of correspondence. So if we study some kind of dieting and are interested in weight, and we have a clear protocol saying, for this purpose, for our study, weight means the weight in kilograms measured in the morning before breakfast on a reliable scale, then we can say our number corresponds to the world. For some variables, there might be many more debates how we can actually measure them. So if we want to measure prejudice, we might want to say for our study we take the average agreement with a range of prejudicial statements. And that's the way a lot of quantitative research is done, but in that research it becomes then even more important for us to think, do we actually believe that these numbers correspond to the thing in the world that we're trying to measure? So before believing or making any quantitative statements, it's important to consider these definitions. It's important to consider how things were actually measured and if that corresponds to the thing that was supposed to be measured. Once we have that, usually we're interested in more than just the value of a variable. We might be interested in the value of a variable and its distribution. For example, in the case of national income, it might be interesting how national income at the moment is distributed between countries in the world. But more often than not, we're interested in relationships. So how are high or low values of one variable associated with high or low values in another variable? Ideally, we'd like to know about causation. So does high income drive high health, for example? Quite often we're unable to do that. We are not able to do that just by observing associations in the data. So that's something to be careful about, and we'll approach that throughout the course. But regardless of what exactly we're trying to investigate, it really helps to explore the data that we have. In class, we'll do that with the Gapminder dataset. I'd encourage you to watch the video regarding Gapminder that's posted on learn.gold. And these visual explorations just are a starting point. So we might just want to explore the distribution of values on one variable. For that, we use a chart that's called a histogram. It looks like this. So this is the distribution of life expectancies, of national life expectancies in the year 2016. And what the histogram does is it creates these spins, so these bars, that put together all countries in a specific range. So these are all countries in a range of 2 years, and then counts how many there are. In this example, we can now see that there are 22 countries with a life expectancy between 71 and 73 years. And that there is pretty much one country with a life expectancy between 53 and 55 years. So this gives us a sense of the range of all values and then which ones are more and less common. Once we've inspected this for our variables, the next step might be to look at relationships between variables. And there we typically use these scatter plots. A scatter plot gives us 1 point for each case, so in this case for each country, and that point is placed based on the values of 2 variables, in this case fertility and life expectancy. And then we can start to try to make sense of the shape of that cloud. Are the points just randomly distributed, then we have no relationship, or do they form some kind of consistent pattern? And here it looks like high values of fertility are associated with low values of life expectancy. So this might be something to get out of this step of visual exploration. That's it for this first video. So what are the things you really need to know? The first thing is that quantitative research is all about variables. And variables, for our purposes, are either numerical or categorical. If they're categorical, they fall into a limited number of specific categories. Operational definitions are really important because they define how we measure, and that allows us to decide whether our numbers correspond to the real world. We might be interested in the distribution and or the relationship of variables, and the starting point for getting at that is visual exploration. In the case of a distribution, through histograms; in the case of relationships, through scatter plots. So please make sure to also have a look at the other video that introduces you to R, to the software package we're going to use throughout the course, and then I'll see you in class.